Uh, They don't, they don't want to admit they were wrong. So, okay, sorry, guys. Okay, so I just I had a friend who's sick, so I was visiting him today, and I didn't really have chance to get to grading. But hopefully by next class, I'll have this weekend, I'll have everything graded. Okay. Okay, so today we're gonna do a mixture of different things. Okay. So, first, I'd like to do is, um, okay, first, this is chapter 4. I'll just save it as it's actually, there's really not much here in chapter 4. So, um, okay, so basically, so basically we're just going to review, we'll start out with reviewing what's the difference between functional and non-functional. Do you remember the difference between them? Could you see? What's the difference between functional and non-functional?
Functional is what the user wants us to input.
Right. And non-functional is, it's more like a general specification, right? Okay. Um, And so the question here is, how do you test? See, if you look at the left side, these things, these are non-functional requirements, right? Like speed, uh, size, I don't know what that is, but speed, ease of use, reliability, robustness, portability, these are all non-functional requirements because they're like, it's not one specific feature, it's the whole program. If it's really, or many features, right? So, so the challenge um, in in is how to test for non-functional requirements, right? That's the issue. In other words, like someone says, I want a program that works fast. Well, how are we going to determine what is fast, right? So they give you an example. We'll measure event response time, screen refresh time. So in other words, the idea is that we should always try to quantify all the requirements to see if we meet them, especially the non-functional. Because functional, you could basically, they're nearly always easy to test. But non-functional, right, is more generic, it's not very specific. Though the size does seem to be pretty specific, but like for example, ease of use. So this is, I think I like this, the way they did it. They want to say that if you want to see if software is easy to use, then the way you can measure it is training time. How much time does it take to train people to use it? Or how much help they have. Okay, I like the first one. That's pretty creative. I wouldn't have thought of that, right? Like people say, my software is easy to use. So um, yeah.
The grade back for the exam.
Oh, yeah. So I said that unfortunately I have a friend who was sick and I went to visit him today in the hospital. So but I hope to do it by I mean I should do it by next Tuesday.
Next Tuesday,
I regraded two of them. So
then
uh I didn't add up the points, I just graded it. But I think that one of them did very well.
one.
Uh, I'm not sure the other one. I just remember one did really well. The way I do it is also is when I grade, if like I try to root for the person, like if I see like someone is doing really well, and then they make like like if I see like they really know what they're doing, it's like I try to give them a little more points per question. I don't know. It's like a psychological thing. Like anyhow, so. Um, so whatever, I'll give it back to you probably on Tuesday. Um, okay, reliability. So how would you measure that? Reliability? So for example, how often the average time it takes to, before something fails. Robustness, like how would you measure it? Robustness means like if it failed, like with SQL Server, if it crashes, how long will it take to bring it back? By the way, do you have what's it called? Where if one machine server goes down, another one takes over. Do you have that by where you work?
Which one?
What's it called? When they have a way where you have two servers at the same time, and then like in SQL Server, so if one server dies, the other one just takes over.
Like a redundancy.
Oh, what's it called? Oh, yeah, what's it called again?
Redundancy.
Or,
Redundancy.
or yeah, yeah, but it's more like it takes over right away, right?
It's like a backup.
Yeah, there's a word for it. Yeah, maybe.
So
Yeah, maybe there's a yeah. I forgot.
A- Availability,
What's it called?
availability.
Uh,
uptime.
I didn't hear what you said. No, it's called failover. That's what it's called.
Yeah.
Failover, which means that if one machine dies, then it automatically fails over to the next machine. And like no one even notices. Like maybe some transactions will be lost, like maybe like a few of them, but and then they'll have to do it again. But in general, it'll just continue as if nothing happened. What?
One time the dog, we have a system for like dog licensing in the city. It went down a while ago. The whole day they were on Teams meetings trying to get it back up. There's no redundancy there.
Well, what happened?
So like at my workplace, like one of the servers for like dog licensing, like in the city.
Oh, dog licensing.
Yeah, so the server went down one day. They said, and I could see my coworkers like they spent the whole day on Teams meetings trying to get it back up. There was no redundancy.
They didn't hit, they
They
what?
could they spent the whole day trying to get it back up.
Did they get it back up?
Eventually.
Oh,
But like, there was no backup like in that setup. There was no automatic.
there was no backup?
There was no automatic like
Uh-huh. Like,
failover.
right, right, failover, yeah.
City job? Yeah. Same.
So you both have city jobs.
BOH. The one I say. How was that?
Hey, cool.
Yeah. So.
Yeah. Uh, it's actually not such a small world because I think you got the job through the college, right?
Yeah.
So they probably place you the same. Yeah. Okay, and then portability, you know what that means, portability? That means like, for example, the code you write could have run on another system, another machine. So like you would look at, say if you want to see something portable, you would like give an estimate how much of the code is hardware is dependent on the specific machine. Okay, so these are all, in other words, you're right, in other words, like let's say you have a C++ program that works on Windows and you want to run it on, let's say, Apple, right? So how is it portable? Could it actually run on or on a Unix machine, right? So so the way you'd measure it would be you'd see, well, how much of it is like Microsoft C++ features, that only Microsoft has, not Unix, stuff.
Virtual machines kind of sidestep that.
I'm sorry.
Like, isn't that the reason why Java uses
Yeah.
Java virtual machines to sidestep that issue?
Yeah. And actually C#, the same idea has I forgot what it's called, but it also has like a virtual machine. But I think C# never took off, so that only runs on, I think, on Windows. But theoretically, the idea was that it was supposed to be able to run on multiple platforms. Yeah, what's it called? The C# runtime environment? I just wonder what it's called. I'm sorry?
I think it's called around, yeah, they're all set.
No, the name, I think is a more runtime environment. What's that called? It might be, it's called, according to AI, it's just called .NET. No, oh, no, that's it. Common language, oh, that's it, CLR. Okay, yeah. So, right, so Java has, what do you say, Java runtime? What's it called in Java? The Java runtime? And, what? Oh, yeah, JVM, Java Virtual Machine. And C Sharp has what's it called again? The CLI, Common Language Runtime. Um, but I don't really think it works on anything besides Windows. Okay, so this is all from chapter 4. There's really not a lot going on in this chapter. So then it speaks about ethnography. So ethnography is really a word from sociology. Okay. And the idea is that the ethnography means that you study like the people who are using this. I mean, it's not limited to programming, but the idea over here would be that when you write a program, you can't like write it without knowing a little bit about the people who are going to use it. Like for example, if you write a type of software, let's say, where people could enter notes, they might be using it in a wet environment, or they might be using it in a dry environment, or they might use environment where there's no internet is very slow. So you have to have, it pays to have an idea of the users, of how they're actually going to be using the software, right? So this, I think, is from the book. So, so for example, let's say accountants, they usually have a calculator when they work, right? They don't usually just have the program, usually have like a little calculator on the side. Um, or like this is another example is like, let's say you have an air traffic controller, right? So the way it works, does anybody know how it works with an air traffic controller? At least from the movies. So the way it works is like everybody gets a section of the sky, something like that, gets their own sector, and then they hand it off from one sector to the next. So basically, let's say you're writing software for one um, one controller, one air traffic controller. So, but you might not realize is that he's actually, or he or she is actually communicating with the air traffic controller sitting right next to them, right? So they're not really looking only at the one screen, they're really looking at the screens of the other sectors to see what's headed their way, right? What's about to come into their sector. So, so that's what ethnography would mean regarding software development, that that you should investigate and see and understand how the software is actually the environment it's going to be used. Okay. Okay, so we're getting pretty okay. So now we're going to get to our first UML, actually not our first UML diagram, but um, our second UML diagram, right? The first UML diagram we did was the class diagram, right? So the class diagram is basically static, meaning that you in other words, if you take a program and you probably nowadays you could like feed it into AI and you can say, hey AI, could you create a UML class diagram for all my code? And it'll probably spit out a beautiful UML diagram. Right? Has anybody ever tried that? I wonder if it works. I'm sure it probably does work, right? Because it's static. There's no real brains, right? All the relationships are in the code. So if you just put a bunch of files in there, it should figure out the relationship and draw all the figures, right? I think it's even software that does it, but I think uh, probably something like ChatGPT could do it without any special software. Um, so, okay, so that's a class diagram, right? That's static, okay? That's what we did. That's what we've done so far. Now, there's another thing. Now, there's two things they're very similar in name, but they're really different. One is called a use case diagram, and one is called a use case table. Okay, and it's very confusing because if you look up if you like Google use case, you'll see different things. So it finally took me a while to figure out that, like if I would Google, let's say use case UML, then oh yes, actually, so this is what a use case diagram looks like. Okay, um, where is it? Uh, So that like this would be like an example of a use case diagram where you see you have a bunch of stick figures and all that, right? We'll explain that in a second. And then a use case table, I don't know if it's even UML, but would look like this, okay? So they're completely different ideas. Okay, even though they have the word use case in front of it, they're actually very different. So let's look at the easy one. Let's do the use case um, diagram. Okay, so basically the use case diagram is actually pretty simple. It only has four parts to it. It has these stick figures, which are called actors. You have the box, this big box over here. That's basically telling us what's inside the system, right? And then within the system, we have different activities that the system could do. So for example, we have an online shopping system and we have four activities it could do. It could do view items, it can make a purchase, but you don't have to worry about the dotted line and include. Right? Remember, we're just doing the basics. We're not getting into, we're not becoming experts in UML, right? We're just generally getting the basic idea of the basic syntax of different UML diagrams. So in this online shopping system, we have an actor, we have a system, which is the box, and then within the box, we have four activities. Those are the ovals, and then connecting each actor with a activity are these solid lines. Okay, so for example, um, we could say by looking at this. So basically, this is a high level diagram of our system, right? Meaning that, um, like if you're like, let's say someone is trying to show, let's say someone new comes to the company, and I want to show them how our program works. So this is like the type of diagram I would show them. It's a very high level diagram. There's no classes, right? We're just showing you what our program does, and the actors are the people who interact with different parts of the program. So, for example, the customer interacts with, when you go the actor could view items, they could make a purchase, or they could log in, right? I'm not sure I'm not sure exactly how to read the dotted line, but okay, but let's ignore that. And then uh, and the important thing to remember is that the actor is somebody outside the system. So the actor is not the customer is not part of our online shopping system, right? That's somebody who logs in, right, to the system, and then they view items and they make a purchase, and then they complete checkout. Though I don't know why they didn't put a line there. Um, and on the right side, we have four other actors, like, for example, we have PayPal, which interacts with the checkout process. We have the credit payment service, which also interacts with the checkout. Then we have an identity provider, which interacts with two things. And then we have authentication, which interacts with everything except for make purchase. Okay, so it's not important to understand exactly how it works, but the point is that this diagram is a high level view of how our system works, right? And the people that they use the system and what parts of it will they use? Okay. Okay, let's look, maybe we should just Google another example of a use case diagram. We have one here. No, that didn't work. Use case UML diagram. Let's see, we have one here. Okay, so let's look at this one over here. So for example, over here, I can't read it. Let's try this one. What makes it, oh, okay. It makes it so small. I'll try one more and then I'll give up. Okay. Okay, let's try this one. Why is it always so small? Actually, let me just copy and paste it. Okay. Let's see if this, we can see it here. So over here, let's try to read this. So let's stretch this up a little bit, stretch this out a little bit, and we still can't read it. Oh well, I tried. But basically, forget it. Okay. I don't know why it's so small. Is there a way to search by size? There is a way, right? Um, oh, I wasn't doing images, that's why. Okay, let's try this one. Now that's what we have. This looks too complicated. Let's try this one. Oh, here we go. Okay, so over here, for example, we have a, could you see this? I'll try to make it a little bigger. It won't let me scroll down. Okay, good. So over here, for example, we have a clerk, and the clerk is able to do one thing, to cancel a ticket. And then we have up here, we have a traveler, and a traveler could check it, could do pretty much everything except for refund, right? The traveler could do all these things. And then we have the railway website, which could do everything also. Problem is I don't know why I can't go around. Maybe if I cut it, then it goes, oh, here. Copy image. Let's try this over here. Okay, at least I could go around that. So, yeah, so over here, we have the, nearly, okay, a little smaller. Okay, so over here we have okay, so over here we have the traveler, which is on the yellow guy, basically could do all these things, could do the check at the pay fare. They could do all the activities except for this one, refund money. And we have the clerk, which could only do one thing, which is cancel a ticket. And then we have the railway website, which could do everything, including refunding money. Okay? Uh, oh, by the way, this is missing our box. Right? There should be a box around the activities in the middle. So, right, like we have over here, it's missing that box. Oh, well. So it's close, but it's close. Okay. Then, okay, so this is a high level diagram. Now, like where I work, they have something called a use case table. Actually, they actually call it a story also. And basically, it has like certain, it's like a very, um, what would the word be? It's a very, um, like formal definition of what the user of what the requirement is. Okay, so okay, so the so this is more the use case diagram is more showing like how the different parts are going to work and the who interacts with which parts of the program. And so it's a very high level uh, diagram. Now this, the use case table, on the other hand, is a very, very specific formal um, a type of it's basically it describes in minute detail everything that could happen with and with this requirement. So as opposed to like a user story, which is like 3 lines, right? This is like could be a couple pages, usually is, right? So for example, you could have a description, um, like a library user requests a loan of one or more books. Then then you have a precondition, which is like what has to be in order for this scenario to happen, what needs to be what needs to happen. Like for example, let's say you have a login scenario, what would the precondition be? Like you have to be on the website, right? Something like that, right? How do you log in? Like if let's say you were writing you were running a use case table about logging into a website. So the first, what would the precondition be? You have to be on the login page, right? And then, and the description would be like log into a system. The precondition would be you're on that page. And then the ordinary sequence would be the different steps that would go, that would happen in order for the, for this, uh, for this use case to occur, right? So it describes in minute detail everything that could happen. Okay. Now, not only does it describe what could happen, it also describes what could go wrong. So, so for example, over here, we have a exception, you see? So for example, in step 3, if the has already reached there could be an exception at step 3, and then we went the system, and then this use case is canceled, right? So there would be an example of in other words, usually a use case table has two different or at least two different scenarios. One is success and one is failure, right? And there's different types of failure that could happen. Like, for example, somebody could forget their password, right? When they a login screen, right? Or another type of failure is they could enter the wrong password, right? So you would need two different like branches, right? The ordinary sequence would be the success. Well, they enter the user ID, the password, they push the button, and they're logged in. The exception would be like if something goes wrong, right? Like they forgot the password, what should happen if they, over here, it has to do with that the library user already has too many books on their card, so they can't check out. But there's other, there are many other things that could go wrong, right? Like maybe the library card is old, right? Uh, like in number two, right? The user doesn't have their library card, right? That's another exception, right? Um, and then and then there's the post condition, which basically means the success. Okay, meaning that if everything went correctly, the post condition is going to be that the library user can take the loan books away and the system has registered the book loan. Okay, so this is like a short type of um, use case table, but you could have much longer ones. And if you Google let me see if I could find it. If you Google, let's say, use case um, a table um, example, but I don't want images. I want to see if it has one here. Uh, oh, by the way, okay, if you look over here, they're using slightly different terminology. Um, okay, so over here, instead of they have description, but they also have a primary actor, stakeholders, preconditions. Again, is what needs to be in order for this to begin. What do we expect, right? We expect it could be they're on the website or something. Then you have the basic flow, the alternate path, which is if something goes wrong, or maybe just another way of doing it. So there's basically um, so that's the idea. But this again is different. This is a use case diagram, not a use case table. Okay. So um, okay. So basically that is it for chapter 4. Okay. So now what I'd like to do is I wanted to do at least one more because we're having our projects due after before the final. So I wanted to do a couple of design pattern. Okay, so let's do um, so let's oops, what was that? So let's do, okay, so the first one I want to do is a real easy one. It's called the factory pattern. Okay. And the factory pattern is, um, it's really good. It's really easy to do and it's a nice pattern. So let's do the fall 2025 factory pattern. Okay, so the case over here is, let's say I have, first let's do the bad way of doing it, and then we'll do the good way of doing it. Okay? So the bad way would be like this. Let's say I have different bicycles, right? And let's say I have a e-bike, um, and then let's say I have um, a pedal bike, a pedal, let's say 27 inch wheel bike. So it's like for like a teenager. And let's say I have a tricycle. Does anybody know what tricycle is? It's like for children, right? A little, a little car. I'm sorry, a little bike that has like just three wheels, right? So now in Maine, let's say I have somebody wants to uh, buy a car, right? So what I could do is I could um, I'm allowed to, um, so, um, so if someone asks me for a bike, I can give them, um, uh, any, any of the three types of bike. Okay, so for example, I could do e-bike, um, e-bike equals to new e-bike, and I could do pedal, whatever, equals to new, and then I could do tricycle. So I could create any bike I want, right? There's no limit. Right? The problem is that often, um, people come to a company, let's say they were new, especially like Amazon, they just laid off who knows how many people. So let's say they hire a new guy, and the new guy walks into Amazon and says, well, I see this code. This looks this looks like it'll do the job. So I'll use this object, right? But the user doesn't realize that maybe it's the wrong object for the job, meaning it's close, but not exactly what should be used, right? But there's no one stopping the new programmer from using the wrong one because it's just available, right? So this guy says, "Well, I need to get my job done. I'll just pick this looks good enough." The person does a little searching in the code, finds something that looks good enough, and starts using it. But the user doesn't realize that it's not for whatever reason, it's not the correct one. So in this example over here, let's say somebody wants to buy an e-bike, and let's say they're only 12 years old, and this e-bike could go 30 miles an hour, and it's sort of dangerous for a 12-year-old, right? So, so I really don't want people who are 12 years old to be buying this e-bike. I only want to give them maybe this bike, right? So, so I want to control which objects are available. So the way we do that is we have what's called a factory. In our case, we're going to call this a bike factory. Okay. Now remember, so we have three different types of bikes, right? Are these concrete classes? Are all these concrete classes?
Yes.
Right. How do you know they're concrete?
They don't, uh, extend anything? They don't interface anything?
Well, Okay, but it's really easy because if you could do new on that type, that means you could create an object of it that's concrete. Okay? So that's the test. That's an easy test, right? If I can't do new on it, then it's not concrete. It's abstract. If I could do new, it's a concrete, right? And concrete classes are always so if I have these three concrete classes over here, how would I treat them the same? Like, is there a way I could join them to be treated in a similar fashion? Remember I said there's a good way to do that?
Inheritance plus.
No, inheritance one way. What's even better way? What'd you say?
Composition.
Well, in this case, it would be using an interface, right? If they all implement a interface, right? But that was a good answer. But in this case, it's even simpler. That's all they have to do. So if they all implement the same interface, right? So let's say, for example, I create an interface over here called, um, I call it, say, bicycle. And then let me just give it one method, void um, ride. Okay, so, and then I want to make all these classes to be similar to each other by implementing the bicycle interface. So I'm going to have I'll say print S out riding e-bike. And then I'll have over here, I'm going to implement bicycle also. And then I have to add the method to do riding. So I'll say SO uh, riding, whatever this is, riding this thing. And then finally, we have tricycle, which will also be a bicycle. I'm sorry, implements a bicycle. Okay, and we have to add the ride method, and we'll do riding tricycle. Okay, so now we could treat that, we have a way of treating all these three different types of concrete classes in a similar way, right? Because they're all implementing bicycle, right? Okay, now remember, what was our issue? Our issue was that we're scared that that the wrong object might be created. Like we might sell an e-bike to a 5-year-old. Right? So how do we prevent that? By the way, where I work, there are like many ways to connect to a database. There are many different classes, and it's very confusing. And we don't have this factory pattern. I just hope for the best. But if we had a factory pattern, it would be much better, because then it would decide what would be the best way to do it, right? It would create the proper connection. Uh, so, so, so I sort of guess and hope for the best. But, but this is the right way to do it. So we'll create a bike factory or bicycle factory. And the bicycle factory is going to have one method called um, create. It'll be public void create bike. And we want to pass in some type of way of deciding which bicycle it should create, right? So let's, in this example, let's do age. Okay, so we're going to create the proper, but oh, I'm sorry, it has a return value. What's the return value going to be? It's going to be a bicycle, right? Because we're creating a bicycle, right? So whichever bike we create, a tricycle, pedal, or e-bike, right? It's going to be type, um, over here, it's going to be a bicycle. So it's not going to be void. It's going to be like that. Okay. So based on the age, we're going to create the proper bicycle. So for example, so if age is less than, let's say 6, we're going to return a new tricycle. Okay. And then if age is less than, let's say 19, we're going to return a new pedal, whatever thingy. And then if otherwise, we just return a e-bike. Okay, I have to do new. Okay, so the way the way we did it now is we are we are we are like deciding in other words, we're preventing the wrong object from being created, right? Because we're saying, wait a second, it's like sort of like we're letting the user of these bicycle classes, we're letting them know how they should be used. We're saying you can only create a certain bike if you have the proper age, right? So this is going to so now we don't have to worry about somebody accidentally creating the wrong bicycle, right? Or selling the wrong bicycle, because we're only going to create the bicycle that's appropriate for the age, right? Um, okay, so we go here, and wait a second, we still could create all these bikes, right? Why is that? If you look at Maine, we could still create all these 3 bikes. So, in other words, we could use our factory, right? We could say bicycle factory equals to new bicycle factory. And we could say bicycle factory dot create bike, and let's do for a 10-year-old. And then we could say bicycle dot I'm sorry, bicycle equals to bicycle factory. I'm sorry, create bike. What was that? Oh, it should be lowercase. Right, so now I could, and now I could do bicycle dot um, ride. Right, so if we run this, it's going to create the proper bicycle for a 10-year-old, right? Does everybody see what I just did? So we have this a factory, which basically is just a class which decides which class should be created. And in this case, it created a pedaling bike. If I would have passed in 20, right, and I ran it, then it would have created it'll create a e-bike. It should, right? Here it is. It created an e-bike. Now, okay, so this code is good, except for one thing. if you look at lines 9 through 12, right, we're still able to create any bike we want, right? That's not good. So we're going to have to do something pretty drastic. We're going to do is we're going to take this class over here and we're going to take it out of here and we're going to hide it inside the factory. So we're going to put it over here and we're going to make it private. So it's only available to the factory. And we're going to do the same thing for the other classes. We're just going to take it and put it into the factory and make it private. And since it's private, the only people that could create it is the bicycle factory. So now we're really locking it down, right? So we put this over here, make it private. And now this code over here will not work anymore, right? So now you can't on your own create these objects. The only way you could create it is through the factory. And now we're really safe, right? So that's the idea. The idea is to hide the objects from everybody except for the factory, and only the factory is allowed to create it. So if somebody makes a mistake and creates the wrong object, it's because they passed the wrong parameter to create bike. So then we say, hey, doofus, why'd you do that? You get yelled at, right? So why'd you pass the wrong agent? But this way, we're protecting which object gets created. And like I said, it's a very common issue when, especially you have a big program and you have lots of different objects and you think, hey, this one looks good. Hey, this one looks also good. Which one do I use? And let's say it's Amazon where everybody just got fired, so you don't know the difference between them. So there's no one to ask, or let's say you're just lazy, so then you'll just pick one of them, right? So this way, we know that you're using the right one. Okay, so that's the idea of having a factory. Okay. Let's see what else. Um, I think it's a little bit too late to start a different one. Okay, so I think we'll call it for tonight, and we'll continue with um, I'll try to do two more design patterns on next Tuesday and also hand back the midterms. Okay? Yeah, because it doesn't pay to start. Um, okay, so I just want to do, well, the idea is I want to do a couple design patterns and then we'll sign it for projects and then, we could do it. Okay. Okay, so have a good weekend and okay, and I'll see you. Okay. It's a great, oh, it didn't stop. Oh, it didn't end?